Bebo White came to UNC as a freshman. And now he's so successful that he gets to talk here. And Bebo at that time put together a number of jug bands, which featured a number of prominent local musicians. I'm telling you this because this will not be in his talk probably, including the hose player, Jacques Lauber.
Garden hose.
Garden hose. Well, I didn't know what they do. So
Now it was a garden hose with a trumpet mouth.
trumpet mouth on it. Also in the band were Jack Garrick, who's now the head of the Brickley Ramblers, and Dave Olney, who had a band out of Nashville called the X-Rays, and is still playing as a sideman around Nashville.
I didn't know that. That's cool.
And Bebo played the jugs. And Bebo is still involved in jug band music in California, which is in dire need of jug band music. And a band called the Tarantulas. Is that because there are 8 people in it?
No, that's a long story, which you hang around, I can tell.
Okay, we'll tell it a different time. But I met Bebo in the very early 90s, maybe even 89, for the ITF meeting, Internet Engineering Task Force meeting, because we were involved in helping people share information on the internet and create collaborative documents. And Bebo had been to Switzerland to a high energy physics group there and learned about something called the World Wide Web that was so worldwide that it wasn't hardly outside of Switzerland. And Bebo actually made it worldwide by setting up a part in San Francisco and when you came back. And so since then, Bebo has been involved with the International World Wide Web conferences. He was instrumental in bringing that conference to Raleigh in 2010 after I resisted for several decades. And doing anything, he would call me and say, are y'all ready yet? And I went, well, there's no actually.
Well, you had to build a
We had to build a convention center and a couple of hotels first. And one of the really nice things is Bebo is in town in part because of his 50th high school reunion. And, but in part to tell us about something, a new movement within the International World Wide Web Conference and the International World Wide Web Consortium about looking at how the web is used not just as an engineering problem, but as a problem of a multifaceted science and how it affects us socially in communications and our other interactions. And so it's delightful to have Bebo, one of the prime beekeepers of Haight-Ashbury.
You're really pulling, aren't you?
I know. There's more I could say.
He's seen my feet.
I saw him at work on a pataphysical slot machine.
That's right, you've done that too.
There we are. Anyway, all right.
Well, thanks, Paul. I want to thank Paul for organizing this, and I want to thank the School of Journalism for hosting it, and you for coming. This is really a nostalgia time. You know, I remember coming to Carroll Hall, as I said, for the free flicks. And I could have never possibly imagined that I would come back under certain circumstances like that. So that said, if at some juncture I start getting a little emotional, just give the old guy some credit with respect to that, so reliving his youth in some ways. So anyway, so what I want to do is I want to talk to you about web science. And I don't know how many people in here are sort of familiar with the field of web science, or certainly by virtue of the name might draw some conclusions about what it is. But hopefully, at the end of the day, you know, you will have a good idea. And one thing I think, given the size of this group, let's be interactive. You know, I don't want to just be the talking head here with respect to that. All right? Now, I do have a couple of caveats. You know, Paul mentioned that I am involved in a number of efforts as far as web science is concerned. But this sort of last bullet says, I want you to realize that a opinions and interpretations of web science are mine, that I'm not necessarily preaching the gospel with respect to like what the Web Science Trust or some of those particular bodies do. So, if you go back to one of them and say, well, Bebo said this, they can say, well, we don't necessarily agree. Okay, let me say something first about the Web Science Trust. I don't want to spend too much time on this. Some of the important things is it started as a collaboration between MIT and the University of Southampton in the UK. And it supports Web Science TrustNet, which are laboratories that are all over the world, such places as Rio and Seoul, South Korea. It's really sort of a burgeoning movement, as it were. Now, one important thing here is that this is not a terribly technical talk, because web science is not first and foremost about technology. And you're going to see this as we go along. In fact, you could say that it's more about sociology. It's more about not the web as a technological entity, but basically the impact that the web has had on society. And so that's where you make this point, is you talk about bridging and formalizing the social and technical aspects and the collaborative applications. That really might give you sort of a clue about what web science is about. And then the notion here, that last bullet, is basically bring together a broad audience as possible. Not just the computer scientists, and not just those that you might think would be primarily involved with the web. But I like to say it also brings together those people who are affected by the web and who affect the web. So that clearly can be just about any discipline, which we'll talk about. Okay, so I have a little mystery here, a little trail. So I got to lead you on before I give you my definition of what is web science. By first asking perhaps, which is a ridiculous question in terms of what is the web? And where else a better place to go to get a definition of the web than Wikipedia? But the interesting thing is, if you look at Wikipedia, it's saying a system of interlinked hypertext documents, blah, blah, blah. It's strictly a techie definition. It's talking about networks, it's talking about protocols, it's talking about hardware, it's talking about software. But is that really what the web first and foremost is? And like I put on here is that even when we talk about it, we talk about the web. And we all know what it is in terms of an application, but we don't ever talk about the email. We don't ever think about the web as being really almost like an object. And we don't think about doing things on it, like searching it and putting stuff on it and getting stuff from it. It's sort of like we have a different relationship with the web. It's not just an application. It's not like any of these other kinds of things that we might see running on the internet. And so, if you look at this, here's some of the perhaps more reasonable multidisciplinary definitions, which you could say. I'm not going to go through all. You can think about it at the very beginning. Okay, it's a system for delivering documents. Or it's a system for collaborative writing, building communities. Or it's a system or a platform for doing e-commerce. And then here's the techie definition. You kind of have to put that in the middle so it doesn't show priority by being at the top. The world's largest library, the world's largest database. If you're a mathematician, you can say it's a large cyclical directed graph made up of web objects and links. That's even more geeky than the computer science definitions. But it means, clearly, if you define it, it means different things to different people. And in fact, you could say in terms of going beyond the technical part, I'm sort of thinking about the social part as well. You can say that it is in fact truly a phenomenon. That's pretty loose. But it's not just a technology, it's a phenomenon. And it's something that has driven technology and is being driven by technology. So it's pretty hard to put your finger exactly on what the web is. And clearly, I don't think anybody is going to disagree with that third bullet in the sense that it says the impact that it has had on society and the way in which it's empowered people, many times in positive ways, but sometimes in negative ways. But it certainly has increased people's capability to communicate, to shop, to do any kinds of things like that. And so, if you think about the types of users, the people who use the web, they all have their own different perspectives. So if you're just someone who likes to surf the web, then your perception of the web is just a vast land, as it were, of possible places that you can explore. You know, there's the serendipity of it. You'll love to find a cool website, something that you didn't ever know was there, or find something that you had no idea anybody would possibly post any content about. If you're a shopper, it's the world's largest shopping mall in that way, because you know full well not only can you probably buy anything you want, but you can do a lot of competitive shopping. You know, find a best price, you know, and things like that. To a searcher, it's a bunch of search results. If you're a dig user, it's a bunch of tags. If you use Pinterest, it's a bunch of themed photos. That's your immediate perception of what it is. If you're a Twitterer or blogger, it's a network of posts. If you're a Facebook user, it's a social network of contacts, etc., etc., etc. And all of these are perfectly good definitions of the web. But it's going to be pretty hard to encapsulate all of these in a nice little tidy definition that you could put on Wikipedia. That makes sense? Okay, so what is the web? Now I'm getting even more cosmic. I got to say, what's science? So this is because we talk about web science. So what's science? Now I like this particular definition, you know, because it incorporates not just natural science, physical science, but it also gives some credibility to the notion of social science that really brings into it the analysis, as it were, of phenomena, data, content in a systematic way. A couple of other things that I like that is, if you look at what Bucky Fuller says, it's this notion that science tries to take these things that we see and experience and put some kind of order to it so everything doesn't seem so chaotic. And clearly to a lot of people, the web is just chaotic. You know, that it's hard to discern. If you look at those perspectives, it's hard to discern any particular order. And of course, Galileo, I like this one, measure what is measurable and make measurable what is not so. Question being there, if that's science, then what can we measure about the web? Because heaven knows everybody can realize there's a lot that can be measured about the web. So that's the definition of science. And how do you do science? I'm not going to go through each one of these particular bullets. You know, we always think about the scientific method. You know, we ask questions, we come up with theories, we design experiments, we interpret data, and these are kind of the traditional ways of doing science, of looking at science, of practicing science. Now, I'm going to call this web science, and have any credibility, might not anyway, I'm going to have to show how these particular tasks, as it were, apply themselves to a study of the web. All right? So that's what we want to do with the web. You know what, like Galileo said, we want to understand it, we want to model it, we want to mine it, we want to poke it, pry it, dissect it, understand it. I put that twice. Getting old. Maybe it's worth saying twice. I'll rationalize that. Predict it and affect it. Now that's kind of interesting. interesting. Because clearly one of the reasons you learn science is hopefully that you can somehow attach engineering to it and make positive change. So those are the things that's what we want to do with the web. We don't want the web to run amok. We might have seen some examples in the past where the web, we lost control of the web, not necessarily in a good way. We want to be able to perhaps prevent that from happening in the future. Now that said, when I gave a definition of the web and I gave a definition of science, you can say, well, all right, given the sciences that we have now, under these conditions, what science explains the web? And if you can't make a rationalization for one of these sciences given this particular environment, then hey, maybe we're ready for a new science. Maybe we're at the point of technology where we need to define a new science. Just in the same way, no one studied aeronautical engineering before people flew planes. Unless you count Leonardo or something. But I mean, it certainly couldn't become, the same serious technology then said, hey, this is a field that is ripe enough, a field that is mature enough, that we have to be able to apply scientific principles to understand it. And if you can't put it into one of these boxes, maybe that's what you need with web science. And of course, you can come back and say, okay, maybe it's computer science. Well, first off, as I can tell you, computer science is a fake science. That's my opinion.
Louder than that.
Okay, and computer science is a fake science. In that sense is that, what you can do in computer science is you can have an idea and you can figure out a way to accomplish it, right? As with a natural science, you're constrained by the laws of physics. There's no way I can decide I'm going to do something that's in violation of the natural laws and manage to do it. In computer science, why not? So is it computer science? And in fact, the whole notion that you see here about computer science is changing. They're basically saying, okay, it's not just man-made computing. We're going to include anything in natural science that involves the transformation of data. So this might be, what goes on, in photosynthesis. That's computing, at least in some cases, because it's transforming data. So the computer scientists have sort of hedged their bets and saying, well, all right, well, it's not just operating systems and networks and things like that. It's really the transformation of data. But it's still not web. It's still not cover webs. And even here, this is something I got from Ben Schneiderman. It certainly gives you an idea. When you think about the web, when you look at on this left-hand column, it's sort of the different aspects of measurement that you might have in computer science, and then really sort of what they might relate to when you talk about web science. So, when you talk about in a metric in computer science, you might say, talk about Moore's Law. But on the other hand, like in web science, page views, that's a measurable quantity. But it's a measurable quantity that really does not have a particular place in computer science or some of these other ones. And you can see by looking at the right-hand side that a lot of these are, in fact, more geared towards the social side as opposed to the technical side.
Can you read those words in red?
Oh, okay. The first category is metrics. That's just things that you measure. So for example, here, if you're a computer scientist, you talk about gigabytes. Yeah. But when you talk about web science, number of songs, number of entities, number of things that are downloadable.
Yeah.
And the second one are topics, like this says computer networks versus social networks, or operating systems and databases versus be it e-commerce, e-government, e-science, e-learning, those kinds of things that we typically have sort of tended to think about have been influenced by the technology. And the third one is focus, in terms of, are you focusing on technology? Are you focused on computers? Certainly in the web, what you're doing is you're focusing on users. Okay? And a big difference there is clearly there's lots of situations when you talk about technology, computer scientists have invented very interesting phenomena that just never caught on. They were geeks. They were for the techie audience. They just did not find a place in society. So that's what that last one, when you're talking about focus, means. All right. So finally, I get to the definition of web science. So here, this top bullet is worth saying, is that let's examine the web. Not in terms of its internal structure, not in terms of its protocol, not talking about HTTP and HTML and all that stuff that makes a lot of people's eyes roll back. Let's think about the web as an organism. Let's think about it as a phenomenon, as a living entity. Okay? And if it is that, if we do think about it, we can perhaps hope to understand how it works and understand how we might be able to affect it. And look at it in terms, it says here, we can look, we're never going to be able to avoid looking at it as a system, but also we cannot ignore, as it were, how the social components of it interact with the technical component. I've got some examples in case. All right, and so this I think we've pretty much come up together. It's a new science that focuses on applications in a lot of disciplines, fundamental curiosity about the web and the way it scales, and then this other one is really social machines have to do is, how can we literally program the web? How can we use it, in fact, to take phenomena that we actually think about as running on the web that do certain, whatever tasks we might want, or measurements, or whatever. And I'll say a little bit more about that. So that's our definition, as it were, for web science. And I like to think this little thing that came out of the Web Science Trust is, in 1,000 years, how will scientists study how we lived on the web? They're not going to, they might look at the technical aspects of it. It's going to look so antiquated or archaic. But what they are more likely to be interested in is how we used it, how it affected our society, not just the fact that it was a technology. Okay? Now, being the geek that I am, I used to like to refer, this is where I'm expressing my own opinion, because the Web Science Trust would never like me. They'd never think of it in these terms. It's saying that, maybe instead of web science, it should be web cosmology. Boy, that's a ringer. That really gets people's attention in that sense. Because if you sort of compare what's happened to the web, sort of with the evolution of the universe, that's not it's not an unreasonable comparison in terms of that. The structure and in terms of the theory. And if you look at these two pictures, what I put there is that which do you think is a representation of the universe and which is a representation of the web? Kind of look alike, don't they, in some ways? So it's not so terribly unreasonable in thinking about structures that way. This, incidentally, is the universe. And that other one is, simply a visualization of what the web looks like. And at least one thing that now the Trust is doing is having this idea of web observatories, setting up web observatories that are collecting data and sort of thinking in the same way of looking at measurable quantities on the web, looking at phenomena happening in real time. The same way, perhaps a little bit of a stretch. If there's any astronomers in here, they probably think that's pretty lame metaphor. In the same way that astronomers or astrophysicists view the universe. Okay, now when we come to that, whether we're talking about the web like the universe or cyberspace or anything like that, and when we talk about those various perspectives, it really all comes down to an issue of scale, to an issue of scalability. And when you look, as this first bullet says, is that when you look at the web at the micro level, when you're talking about web pages and links and HTML and, all those kinds of things, it is an artificial artifact. It is a piece of engineering. But whenever you step out of that little confined space, namely, whenever you put links on your pages, it becomes more than technology. Because there's no technology that's going to be telling you who you got to link to. And there's no technology that's telling you how many links you got to have except for one. It's pretty dumb to have a web page that doesn't have at least one link. But after that, that's where the real complexity lies. That's where the real utility lies. And that's where, instead of being governed by technological rules, it starts being governed by sociological rules. When you make the decisions, like linking and referencing and those kinds of things, it's nothing that technology is telling people to do. So it becomes, something like this. If you look on this right-hand side, the sort of notion is that you come up with the idea of something to use on the web. So that's the creativity element, the idea. And then you figure out how to implement it, how to design it, how to add the features that you think will enable you to accomplish your goals. And that's all the micro part. But the complexity and the collaboration part comes, as I said, when you start linking, when it goes to the macro scale. And on this side is basically, that's the scale, that's the arena where we're going to start thinking about it as a science that is worth examining. Okay? And why would we do that? Because clearly there's lots of questions with respect to the web that you can't answer in other ways. I say here, the dynamics and the evolution. If we had known exactly how the web was going to evolve, maybe we wouldn't have had the .com bust. Right? Because it was driven by the web. We wouldn't have issues like we have with respect to security and privacy. Those are all possibilities. There's the deep or dark web. That's that part of the web that you never can see, that Google doesn't get to, that's hidden inside databases, that's hidden behind firewalls. There's that part. There's the whole thing of sampling. If somebody tells you they know how many pages are on the web, it's probably more accurate to say you know how many galaxies there are in the universe in terms of scale. Search, artifacts of social interaction, and then topology. What does that look like? And these are things that you can speculate about, but it's very hard to come up with any kind of robust explanation or robust proof of it. And so, here's an example in terms of the deep web. So if you look here from Jim Hindler, just that little piece at the very top is the web that we're seeing with Google or any of these other search engines. The majority of it is out there. It's like that light from the beginning of the universe that hadn't gotten here yet. Okay? And that's what we really want to understand how it works. And involved in a lot of different areas for that. How do we explain that? How do we exploit that? How do we capture that information? Okay, I want to give you a couple examples and sort of the roots behind web science. Now, for anybody who has created a web page, you know that when, as I said before, there's no rules with respect to how many links you can have on your page, except for one. As many as you want. Now, if you extrapolated from that fact, you would say, well, the topology of the web has got to be random, because if anybody can just put as many links as they want, how can there be a structure? Well, what has actually come up in evidence is that, in fact, the web is a scale-free graph. That it does have structure, despite what we would anticipate in terms of it being random. So the issue would be, in some ways, what really drives it? How did that happen? Is that a law of science that we didn't know was happening when we decided how many links we put on there? But in fact, that's a phenomenon. Basically, what scale-free is basically a fractal view, as it were, of the topology of the web. That, yes, oh, here we go.
Explain better what you mean by scale-free there.
Scale-free, I think when I threw out the notion of...
Obviously, relationships, what is being measured, what's being...
Basically, what scale-free is indicating, actually, I've got a second slide that might say a little bit more about that, is the notion, too, that it's rather than being, and this is once again a universe-type comparison, rather than being a random, inhomogeneous collection of sites,
Yeah.
then what it actually does is accumulate, as it were, into major sites or clusters.
Yeah, I get that.
Right? That's actually what you see. That's actually what's driving it in that sense. And these aren't necessarily clusters that are, say, driven by Google or something of that nature. There's other reasons why you've got a lot of inbound and outbound links within some of these clusters. And a lot of that is driven, as it were, as we say, by social phenomena. All right? That's really what that means. And this predates web science, but it is in some ways, I say, a root in the sense that it does indicate, in some ways, that there's a deeper understanding that's happening with respect to it. And here's a quote that I found, and basically the notion, too, is that, we can talk about free will with respect to the web or things like that, but it says, when living organisms, when allowed to make freely willed decisions, somehow end up following some kind of mathematical law. It's built in our DNA. And so consequently, since it's built in our DNA, then we are subliminally, perhaps, transferring that when we use the web. All right? And so when I say, let's make a case for web science, how do we understand these things? How do we understand the impact of the web on business models? I made a reference to the dot-com bust. One of the things I like to examine with some of my students is the fact is that maybe what happened in the dot-com bust is that people had the opinion that they could just take a traditional business model and plop it on the web and think that it would work or work the same way. But the web fooled us. The web basically said, it's not, because this is a totally new ballgame. This is a totally new arena. And those traditional models are not going to work. The legal issues, how people use it, etc. There's a lot of it. And this last one I say, in terms of case for it, web science is bidirectional. We can say we're learning about the web, but also the web is learning about us. I made that statement once and somebody said, does that mean the web is the matrix? And, and it's a little bit more perhaps than talking about, like, what is Facebook learning about us? But, there's a lot of different phenomena, things in there that are happening, in two ways. And we can perhaps then also use what the web is learning about us, then is part of those phenomena that we can perhaps tap into. Okay? And so you can ask these things about what's the appeal of systems like Facebook? Why has Facebook been so successful? Or how do we address some of these other issues? How can it affect the way we do science? There's the notion of the web of objects and big data. And that last bullet, I think, is the key, is that you can ask those kinds of questions, but those aren't technical questions. You're not going to trust the computer scientists to come up with technical solutions or answers to those questions. They're multidisciplinary questions that are going to require multidisciplinary answers and solutions. Okay, now, example, look at this. Facebook generates terabytes of data per day. Right? So it's learning a lot about us. Why can't we tap into that data? What can we learn from this? And I don't mean learn for directed advertising or something like that. What you think about what Facebook does. How else can we possibly view that as the web as a sociological entity? So I asked the question, how many people know who that is? Anybody know who that is? I should have said I'll give you a prize. You might recognize his name, certainly. That's Stanley Milgram.
Oh,
And if you aren't familiar with Stanley Milgram, he's the big 6 degrees of separation guy. Right? So-called small world. Right? And if you've read anything about Milgram, you say, well, how did he reach that conclusion about 6 degrees of separation? It's pretty funky. It's pretty brute force, because basically it was sending postcards, between cities, say, if you know somebody who you think knows somebody, give me this postcard, tell them to send it. So it was pretty funky in terms of how he did it. To come up with this notion that there are, in fact, at most 6 points between any two people. Well, 6 degrees of separation, is it really true? So if you got the fact that you got 1.25 billion people on Facebook, that's a pretty impressive sample. You might be able to figure out whether or not there's any truth to it. A lot better than Milgram's postcard. And so, how could you possibly test this? Facebook opens their data up. How could it possibly be do a study using the web as a laboratory and using its data to see whether or not that social phenomenon is in fact true? Well, in fact, guess what? 6 is too many. 6 is too many. In this particular case, if you look at that data, one of the studies that was done, it says 92% of users are connected only by 4 degrees or 5 hops. And as Facebook has grown, it's reducing even more. So Milgram was too liberal, as it were, in terms of making that assertion. But it's really got more of an empirical basis behind this than perhaps his original experiment. But of course, it's perfectly valid to ask yourself also the question, does Facebook represent the real world? I don't have an answer for that. To what extent does Facebook represent a good sample of reaching these sort of conclusions? Or some subset, as it were, of Facebook users? I mean, this very much resembles Pareto's law, which everybody's familiar with about, what the ratio between, in this case, Facebook users versus friendship links. So that's an example. But one thing we like to think about too in web science is it's an intersection of disciplines. So what you're trying to do here is that web science is in the middle. And these are, as I said before, all these disciplines that contribute to web science, that have a role in examining the web, and have an interest in examining the web because they are affected by the web. Math, media, law. Media, of course, will be of particular interest to the people in this building. The mathematicians, great laboratory for doing those kinds of things. So it's an intersection of disciplines. It's not just tech. It's not just the CS people. And in fact, if you look at this, the CS people are pretty much represented as peers. They don't have an advantage. Computer science does not own the web anymore. And they're going to try to affect the web, but many of you know that, as I said, computer scientists have come up with protocols that have been complete busts, that the world has not adopted. So you're not going to have computer scientists making decisions, even if you wanted them to. You probably don't want them to, on some of the issues that have to do with the web. And I like to think, too, is that all of these disciplines are like cells. And one of the issues, too, in web engineering is how do they communicate with each other? So if I'm talking to a sociologist and I start throwing out terms like RDF, OWL, HTML, XML, eyes are going to roll back in their head. They know what I'm talking about. And I'm sure that sociologists or economists or any of these other people, they can come up with terms and with concepts that would totally blow other people away. So one of the big issues in sort of having this model of this multidisciplinary nature is how do you communicate that? How do you exchange DNA in order to perhaps reach whatever your goals might be? Because if you can do that, as we said, one of the main goals of web science is to be able to affect the web and affect those disciplines that play a role in the evolution of the web. So, if we look now, we try to make a case for web science. If we say now, what are the goals of web science, we can say to understand what the web is as an entity, to engineer its future for our benefit, to make sure that it doesn't play any tricks on it. And it does, in fact, become something that empowers us in a meaningful way. Now, you can ask the question here, you don't need to read that. So if I make a thing about it as a science, okay, scientists have a very preconceived notion about how you do theories and conduct experiments and have conjectures. So, how do you come up, what would a scientific conjecture on the web look like? Or do you really have to think about theories that you can prove in the traditional way, right? So if you make the statement every page on the web can be reached by following less than 10 links. How on earth can you prove that?
Can't write an equation that proves it.
Can't, come up with some, as I say, scientifically robust way of ascertaining that statement. So, if I can't practice it that way, or even things like web download times follow a log normal function. How am I prove that? I can't look at, the download times that everybody has when they look at content on a web. So I can possibly come up with some resemblance of proof of that particular conjecture. The notion here is that, once again, maybe we're in a new science. In the notion that we should not necessarily seek theories that we can come up with closed proofs for, but things that really show the preponderance of evidence of truth. And the mathematicians got this a long time ago in the sense of saying, all right, we can't prove some of these conjectures, but, if it isn't true, it's going to be, we're talking about numbers at a scale that doesn't make any difference to us anyway, right? So, other sciences have basically said that closed proofs, we are not absolutely necessary. It's predominance of evidence in some ways. Thinking about, in fact, that once again, that the web or big data, when you think about these, can in fact be our guide. And so if you think about, I would say I like to use this, and you think about the state of the web now, there's this unstructured model. Is that, in electricity, in the 1800s, you had all these different devices, electrostatic generators and Leyden jars and stuff like that. And nobody knew how to put them together until along comes Maxwell and he comes up with these. And so not only is he explaining how these things work, but it's enabling you to make predictions about what you can do. Now, I'm not going to stand up here. I wouldn't lose totally credit if I came up here and said that the web can be reduced to a bunch of differential equations. You know that I'd lost my mind. But the notion, too, is that showed the structure, a structure that was previously unknown in studying electricity or electromagnetism. Okay, and when you talk again, once again, about engineering, unfortunately, in the case of the web engineering came before web science. Well, that's a pretty different way of doing it. But what does it mean when you use the term about engineering the web? I already used the analogy about aeronautical engineering. So in some ways, when we talk about it, aren't we more talking about this notion about how we can perhaps domesticate the web? How can we hybridize the web? The same way people, put different plants together to come up with something that has the more desirable characteristics. How can we possibly do that in the case of the web? And therefore change its behavior instead of basically assume some sort of nature of natural evolution. And so when you look at that, you can say that you can come up with examples that I think you could, on your own, is to say, what are some of the things about the web that are desirable that we want to encourage, and what are some of the things that we have seen that are undesirable that we would like to discourage? And so that's engineering in the same sense of saying, what can we possibly do, to affect maybe certain diseases or certain things like that? So isn't it like domestication, or isn't it like something that's comparable to designer web, as it were? And so I would say then is that there's lots of opportunities in web science. There's lots of unexplored categories, especially with respect to, how do you build relationships with these other disciplines? How do you get input from these other disciplines? What can you learn from them? And how can you affect them in positive ways? So it's really coming away with web science of having new relationships with social science, law, economics, psychology, every one of those colliding disciplines that you saw on that previous slide, because you have to think that these disciplines are eager to work with the web scientists, because the lawyers, there's no lawyers in here. If you look at what's happening here is that, when you deal with internet law and web law, it's almost like, making it up as they go along. Or having it driven by cases. How can you possibly, in fact, affect that? And so, the challenges that you see in something like web science is, how do you communicate with these disciplines? As I said before, how can you come up with non-technical ways of showing the complexity of the web? I mean, that's some credit that you've got to give to Milgram, in the sense that it was a non-technical explanation, even to the point if you wanted to think about 6 degrees of Kevin Bacon. That's hardly technical. But clearly it's something that people could perhaps identify with and understand what the issues were without trying to say, this is a small world graph. What's that mean? And be able in that way possibly to affect, as I said a couple of times, the role of the web in those particular areas. So, I hope this has been a good introduction. Some of you get really turned on by this. It will not be too late to participate, as it were, in the Web Science Conference that's coming up in June. The nice thing, as I said, about the Web Science Conference, it's not a techie conference. It is more designed for people from the social sciences, for the historians, for the economists, for the psychologists, for the people that are interested in HCI, for the lawyers that are interested in such things like network neutrality or digital rights management. Because once again, those are things that if you just leave it or think about it in terms of a technical solution, it isn't going to work. And the last thing I had here is sort of a shameless promotion. Is that I am doing a MOOC on web science in the first quarter. At least I think I am, unless I chicken out. Because it's pretty hard if you're familiar sort of with the MOOCs. So, that said, thank you so much for coming. I'm certainly willing to entertain questions, comments, criticism. Somebody wants to tell me that I'm full of it. I'm perfectly willing to accept that. And I'm really interested in knowing, what are your opinions about this? I do have one other slide, but I think Paul has somehow preempted me on that. And that is, maybe some of you might not realize who that guy on the far right is. He's standing right back there. Okay, so,
You're not going to play up with what it's you.
well, is that obvious?
Yeah, it is.
Of course, that's the guy that had more hair, and it was not dark, and he didn't have a beard. But anyway, Paul sort of preempted me on that. And part of this is saying, it has been quite a trip. Starting here in Carolina and finding myself back doing that. I really want to thank all of you for taking the time. And hey, I had my email on the previous slide, and send it my way. Yes, sir.
I've been waiting years to ask this question.
That's a good setup.
If you took the web and you abstracted it one more level, so you deal with bits of information, maybe words would be one type of bit, photographs would be one type of bit, audio would be one type of bit. They don't care what it is, don't care what category, just bits of information. Wouldn't you, and you measure and you monitor big cities to smaller cities, big countries, time of day, but wouldn't there be something like the ocean tidal waves? I mean, isn't there something up there working, you think?
Well, that's absolutely. I mean, I think once again, years ago, people would have looked at tidal motion and say, that's completely random. And they were not perhaps recognizing that there were so many forces that were in effect that do it. And it's not, maybe some elements of it are random, but, you know, how long did it take for people to realize that the moon affected the tides? Or, you know, any of those sort of things like that. Or even, once again, I like the notion of the fractal nature. When you talk about reducing it, you know, the old physicist in me says, you know, the whole notion of saying, you know, every time you get to one level, isn't there something a little bit lower?
Yeah.
Is that, you know, in particle physics, isn't there something a little bit smaller?
More than bits.
Some that's a little more fundamental?
Yeah.
And this sort of ties into that. Basically, the whole notion, you know, there's these theories about that the universe is nothing but a great big computer that's just transforming bits of data, and everything we see is as a result of this program, as it were. So, absolutely. Absolutely, I agree. I don't have an answer for it. That's probably why I'm blathering around like this way. But, no, absolutely, I agree with you. And the nice thing is that, you know, the web science, that kind of stuff is perfectly a topic of discussion. No, I think you're right. There's no notion that we actually really understand is that we're the most primitive level, either of data or either of the representations of here. And then the things we see, you know, are basically human abstractions. Now, maybe it's going to be something more fundamental than that. Yes, ma'am.
Is there a role for government in this?
Absolutely.
And is there a parallel with biomedical research where the government invests in some kind of basic research that the private sector is not going to do, and then the private sector picks up at...
Absolutely. When you talk about biomedical, I mean, this is related to web science, but if you look at things such as the semantic web and big data, bioinformation, that's one of the hottest topics around. In terms of, you know, how can you take, just like, I mean, my example of the small world is, you know, pretty trivial in that case, but clearly there's a great deal of potential in terms of an area like biomedical. Because, you know, I like to sometimes think, and I've given some talks about thinking about, you know, the web as the world's largest laboratory, you know, where you've got all this data, and all you got to do is design the experiments and find the patterns, and there's probably an enormous amount of great stuff out there that when you put them together, boom, it's just going to be amazing. And biomedical is a good way. As far as government, clearly, once again, I think anybody that's involved in government can realize the value of open data. The whole idea between, you know, if you've got data and government like that, you know, if there's no real reason to keep it private, like for legal reasons or privacy reasons or things like that, make it public, because people are going to find insights that can perhaps benefit you that you never imagined. Or they can put things together. The potential there is saying, you know, the web is an incredible repository of data. But when you put data together, and associations that perhaps you haven't seen before. That's the process of turning data into knowledge. And that's what we want, isn't it? Why are you here? Why are you in UNC? That's what we want. Yes.
So who would be on the top 5 list of top web scientists that I should follow, or so anybody else in the room should follow?
Well, I think in terms of that, yeah, I can give you a list, like the folks at Southampton, you know, Dave DeRoar, Wendy Hall, or at RPI, Jim Hindler. Yeah, also, I think at Southampton, I have to include Nigel Shadwell, who, of course, recently just got knighted. So somebody's taking it seriously. So, yeah, I mean, those, if you look at the folks, if you go to the Web Science website, you know, you can see the participants that are involved in there, but you're also going to see some promo in terms of saying, why isn't there anybody in Chapel Hill?
Why not?
Why isn't Chapel Hill part of WSTNet?
There probably are some information sciences.
Who's doing web science at that? Because, but if you want the people that are perhaps most active, the ones that are publishing the most, you know, that's certainly a great start. And that, you know, Wendy and David DeRoar and West.
I'd say Barabashi.
Yeah, well, yes, but
Barabashi's
he's-
early as a whole concept.
Well, yeah, I mean,
thing
you look
here,
at him and you look at Schneiderman, they were kind of, and Huberman, they're kind of on the edges, so they kind of found justification for what they were doing before.
But what I'd say in Barabashi's case is that he did exactly what you said, looking for the power, looking at how networks work through Duncan Watts' work. In fact, starting with the 7 Degrees of Kevin Bacon stuff, that's where Watts got his entry,
Sure.
and then Barabashi took the same data set. Then, since then, he's used basically the same research structure to look at cancers spread. So the Barabashi lab looks at social phenomenon and at physical and medical phenomenon. There are not many people that were able to get all of that in your head, and whereas it's not particularly web science, it shows the power of that.
That's why I refer to it as a
bound
root
research,
web
and then being able to see
Yeah.
the pattern and then transfer it out. That's a very successful science core,
Absolutely.
if you can say that.
What kind of relationships do you find? Similarities?
Yeah, you can use exactly the same tools to do. So there's something called the new science of networks, which anybody who's been in my classes been
Data science?
to. This is looking at Watts and Barabashi largely. There's a couple of documentaries out of Australia that show it, but if you look at where Barabashi's book Burst goes, it's the next one that's about predictability, and that's exactly what NSA is using, exactly his research to know where you are, how you are, and how you move. So you don't even need individuals, you just need a high probability of an individual behavior. So, and you guys, and the most deviant people are about still 90% predictable. So college students are the most deviant, not in the way that you're probably thinking.
Not the way they aspire to be.
But they're less routinized in their behavior. So there are those guys that are on that have taken something out, particularly the other people that are in network.
Absolutely.
Those two guys in particular. Watts is interesting because he went from physics. Both of these guys were physicists originally, just as you were, which I found lovely. Watts has actually done a lot of PR work and talks to PR people. So,
Smart. Smart.
Yeah, well, I think actually Barabashi did a little better, but because Watts went to work for Yahoo and then for Microsoft. So he's, whereas Barabashi's kind of gone in other ways. But I love this, and I love that one of the things is that in this sort of bound, semi-predictable living system, the importance of it is that it's a transference of the tools.
Semi-predictable, semi-permeable.
Yeah, I think that's probably just predictable and permeable. Exactly. It's wonderful. And take somebody like the physicist ridiculous who already realized that what looks solid is a little less solid than we thought.
So, actually, I'm questioning if, I don't know if Paul has got any mechanism, but surely if anybody wants these copies of these slides, we're welcome to.
We can
I use them all under Creative Commons, so
Yeah.
you can do whatever you want to it, except make money, I think.
You can have an option on it. Okay, that's good. I didn't want to monopolize that.
No, no, no.
I really love that
I said I wanted-
how you and others started out in physics, an area that is dealing with the problems that directly that go to Don Shaw's question, and that they bleed out, answering questions in much broader senses in Watts's case in PR, and in Barabashi's case, human predictability, cellular predictability, and information flow predictability is really pretty key.
So I want to hear from you. When you go back and think about this, give me your input. And if I'll give you credit, I'm not going to steal it. But if you've got any,
Well, you probably ought to say something. Like a class in here, and these are kids in a class called community journalism, and it's very web-oriented. We've got a online-only lab newspaper for Carver, coming out every 2 weeks, and then we've got one from inner city Durham that also has a print component because of the digital divide. And I'm really curious. Y'all, we have a class blog, and I challenge all of y'all to send me at least a sentence describing, perhaps, maybe that's what we ought to chat about. How does any of this apply to what we're doing, what you're doing? How does this impact the Carver Commons? Does this change?
absolutely. Or what can you learn from what you're doing? Yeah, both ways. Absolutely. I encourage you to do that.
Well, I want to hear that.
Yeah.
Oh, you want to hear that?
He's not even in my class.
He's doing spot
There you go.
So.
Go ahead.
Yeah, I mean, like, the thing really struck me that in your slides was, like that notion between differences in understanding of electricity. And I feel like in a couple of years we might have a formula, that you put all this stuff in and you say, okay, I need like 10,000 visitors a day and I need to write stories like this, or I need a story to go viral, and here is, a couple of integrals and all the scientific background on how to make a story viral.
And you never know. I used to have a slide, I think you never know where these things might come from. In the sense of saying, certainly many people here are going to be familiar with PageRank. That's the algorithm that Google uses. But do you realize there are also examples of that equation that occurred in nature? So maybe there's a natural law there. Maybe there's, once again, something that,
Here's an example of there. We had something going viral in the system. I envisioned like a little geyser going off, right? Like a little hotspot shooting everything. You can actually see that happening all over the world.
absolutely. And some of it you can't explain, like, why on earth did Gangnam Style go viral? Good. I'd love for somebody to explain to me, whether that's, says something about the downfall of, I'm sorry.
I'm going to call on one of my students, okay? I've got a couple of my student editors here. I want to hear someone to talk to me.
Well, first of all, thank you so much for coming to talk with us today. Really enjoyed your talk. A lot of it is a little over my head.
You got a job.
But I did really like the new idea of making web science, like science we typically think of chemistry, biology, physics, more in the natural world. So that's like a new idea that's been implanted in my head. And we were talking about user perspectives of the web. And I guess I come from the blog side of things. So I see the web as an interconnected web of blog posts, especially with like online newspapers like Huffington Post and Carver as we continue to move forward with research in web science, would that include things like Google Analytics and figuring out, how many visitors per day? And how can we use that to our benefit as Durham Whites and Cargo Commons?
Absolutely. I mean, that was what we talked about on that thing about why web science is not computer science, is that, Google Analytics is looking at a different kind of measurement that 10, 20 years ago didn't exist. You didn't have, it was not a meaningful concept to think about that. And now, of course, what you're seeing in the case of Google Analytics is a major contributor, as it were, to an online economy. It's worth billions of dollars, if not more. And what can we learn about that? Absolutely.
And I think that, when we're doing this kind of research, it's important to think about how not just, we use Google Analytics for our benefit to get as many hits as we can per day. Of course, that is important, but also doing this research for the sake of acquiring knowledge.
Yes.
It's like, what's
Well,
the dynamic?
another argument for doing that, once again, is we know how fickle. We know how fickle the web is. We know how fickle the community is. So, if we don't try to understand what's going on, and, we'll get left behind. Because it's constantly evolving. Absolutely. I agree with you completely. It's a very good perspective. Doing good job.
Two more.
Yeah, I guess when I was listening, I work for the Durham Voice, which covers inner city Durham, and so talking about how the web affects people I was thinking about how the lack of web access affects people as well, because in a place like inner city Durham, there's less of a penetration of technology and access to the web, and so not only, I know we kind of measure how everything is online, what about those people that are offline? What are the people that are left out? How does that affect?
Absolutely. I mean, this, once again, is one of those factors that is very instrumental in hopefully quantifying some of the effects of the so-called digital divide in terms of it. I agree with you completely. Is that one of the sort of, is the penetration of the web creating, as it were, a society of the haves and the have-nots, the elitists, those who have access to the technology and those that don't? You certainly hope not. Is the access to data doing that? I mean, some people have even gone so far as to say things like, in the past we've seen wars over land and oil and water, etc. What's to say in the future there may not be a war over data between the haves and the have-nots? You don't want to see that. And this is clearly a major issue. And that, once again, is an example of saying there's no technical solution for that. You're not going to come up with a nice little thing, but what you can come up with clearly is, those impacting factors. At least if it happens, you can come up with a good way of understanding why it's happening. Not just social. Does that make sense? Thank you so very much. Thanks again to Paul and everybody for coming.
Thank you so much, Bebo.
Yes, buddy.
Absolutely wonderful.
Absolutely.